हो गया बताएं. Good morning students, welcome to the class. In today's class we will discuss few more basics related to the triangle. Okay, and this is our third video class. In very first video class we discussed the basics of the triangle along with the basics of the polygon. Okay, and in second video we discussed the previous year questions of the series. In today's video we are gonna to discuss further basic concepts and the rules related to the triangle. Okay, so let's start. In today's class, we will discuss firstly the condition of the formation of triangle. As I have told you that we need three sides just to construct the triangle. Okay, and what is a triangle actually? Triangle is nothing but area bounded three sides. We have already discussed this. Okay, suppose I'm providing you three length of the three line segments. As we know that we need three line segments just to construct a triangle to bound an area with the help of three sides. So suppose I have three line segments. Length of first is 3 centimeter, length of second is 2 centimeter, and length of third segment is line segment is 5 centimeter. Is it possible to form a triangle with these three line segments? And I would say no. We can't form a triangle with the help of these three line segments. So I'm saying that we can't construct a triangle with the help of these three line segments. So we just need to understand what are the conditions to form a triangle. Okay, what are the conditions to form a triangle? Okay, before starting, I just want to tell you we don't have any kind of PPT today to discuss here. So I will write here everything, and you just have to listen everything very carefully. If you are listening everything very carefully, you are going to understand everything. Okay, so let's start. So in today's our first concept will be the conditions for the formation of triangle. So we will discuss first the conditions. Okay, so what is the first condition for the formation of the triangles? So first condition is that first condition is that sum of any two sides of the triangle must be greater than the third one. I would say again, sum of any two sides of the triangle must be greater than the third one. Okay, so let's take the example over here. Suppose length of the sides of the triangle is A, B, and C. Length of the sides of the triangle is A, B, and C. As I told you that sum of any two sides of the triangle must be greater than the third one. So you can say if you are adding length of any two sides, that addition must be greater than the third one. So if I add A plus B, I would say A plus B must be greater than C. If I add B plus C, then B plus C must be greater than the A. If I add A plus C must be greater than B. So this is the first condition. Okay, this is the first condition, and we have to keep it in mind. Now, as we have an example over here, the length of the three line segments is 3 centimeter, 2 centimeter, and 5 centimeter. And I said you that the triangle cannot be constructed with the help of these. Why can't we construct the triangle with the help of these line segments? Because the length of the line segments is provided here 5, 3, and 2. And we discussed the condition over here that sum of any two sides must be greater than the third one. So we are going to apply this condition over the example. Sum of 5 and 3 is 8, and 8 is greater than 2. So first pair following the condition. Now we have to apply the same condition on the second pair. Sum of 5 and 2 is 7, and it is greater than 3. Again, the condition is applicable on the second pair of the sides. Now if we are going to add 3 and 2, sum of 3 and 2 will be equal to 5. So last pair, sum of the last pair is not following the condition. So we should apply the condition on each pair of the sides. So I can say here sum of these two sides is equal to the remaining third one. I can say the triangle cannot be constructed because it is not following the condition. So condition says that sum of two sides must be greater than the third one. If sum of any two sides is equal the third one or less than the third one, okay, then triangle cannot be constructed over here. Okay, so I hope you have understood it in a better way. Now we will discuss the second condition of the formation of the triangle. So second condition says that difference of any two sides must be less than the third one. Okay, difference of any two sides of the triangle must be less than the third one. Suppose length of the sides of the triangle is A, B and C. Okay, and as I told you that the difference of any two sides of the triangle must be less than the third one. So if I take A minus B, okay, A minus B, so difference of these two sides must be less than the third one. So here is the difference of A and B, so it must be less than the C. If I'm going to take the difference of B and C, B minus C, it must be less than A. If I am going to take the difference of A minus C, so it must be less than the B. Okay, now you have better understood this, that sum of any two sides must be greater than the third one, and difference of any two sides must be less than the third one. Okay, with the help of these two conditions, we can calculate the range of a single side of the triangle. How we can calculate the range and what kind of questions are asked based on these conditions, I'm going to discuss the questions also over here. Okay, firstly, we will learn how to calculate the range of a single side of the triangle. Okay, suppose length of the sides of the triangle is A, B and C. Okay, these are the lengths of the sides of the triangle. Okay, if I'm going to talk about the side C, and we discussed two conditions over here. First condition was that the sum of any two sides of the triangle must be greater than the third one, and second condition was that difference of any two sides must be less than the third one. So I can say these conditions, in other words, that a single side of the triangle must be greater than the difference of any two remaining sides. So here I'm talking about the side having length C. So I can say C must be greater than the difference of remaining two sides, means A minus B. Okay, C will be greater than the difference of A and B, and C will be less than the sum of A and B. So I can easily calculate the range of side C. In the same way, we can calculate the range of side B. I can say that B can be greater than A minus C, and can be less than A plus C. In the same way, I can calculate the range of third side, and what is the length of the third side? It's A. So I can say A can be greater than B minus C, and A can be less than B plus C. Understand? So it is the method of calculating the range of any two side of the of any given side of the triangle. Okay, now I will discuss 2 or 3 questions based on these conditions, that how to calculate the numericals based on these conditions. Okay, so I'm going to have a question based on these conditions. The question says that, okay, I'm writing the questions just in a short form, and you have to understand me that what I am delivering here, what I am saying here. Okay, so let's take a question. Suppose the sides of the triangle is provided like 19y and 25. Okay, 19y and 25, these are the lengths of the sides of the triangle, and he is asking us the value of y. Okay, so we can provide here a fixed value of y. Here we can calculate the range of y. Okay, and 4 similar kind of options will be provided to you in the question. Okay, so the numerical values of the two sides is provided. The length of the first side is 19 and the length of the third side is 25, and we need to calculate the range of y over here. As we discussed, that y must be greater than the difference of these two given sides. Understand? So y will be greater than the difference of 19 and 25, means 6, and y will be less than the sum of these two sides, means 19 and 25. So sum of 19 and 25, it will be 44. It means I can say that if I'm gonna to place anything at place of y, but that anything must be greater than 6 and less than 43, we can construct a triangle. And so I mean to say we can place 7, 8, 9, 10, 11, 12 up to 43. Anything, any number can be used at place of y, okay, and we can construct a triangle over there. So a simple kind of questions have been asked many times in the question paper based on this condition, that kind of question. Okay, what another type of question can be asked over there? I'm going to give you another example. Suppose length of sides of the triangle is 32, y 46, okay, and examiner is going to mention in the question that y is integer, y is integral, okay, value of y is integral. It means y cannot be in decimal form, okay, y will not be representing a decimal value, okay. Then he is going to ask that how many triangles can be formed over there in most possible ways, okay. How many triangles can be formed, understand that? So firstly we need to calculate the range of y. So what will be the range of y? Value of y will be greater than the difference of these two given values. So the difference of these two values is 14. So I can say value of y will be greater than 14, and the value of y will be less than sum of these two given sides. So sum of these two given sides is 78, okay. So this is the value of y, means range of y. But the examiner asked us that how many triangles can be formed here, and he has mentioned that y is an integral value. Integral means it is not in decimal form, okay. So we can use 15, 16, 17, 18 up to 77, okay. Any value can be placed at place of y, okay, and we can construct a triangle. So total possible values of y will be, take the difference of 74 and 14, 74 and 14, it will be 78, sorry, 78 and 14, it will be 64 and minus 1. So I would say that 63 possible triangles can be constructed, okay. 63 triangles can be constructed over there. So that kind of simple questions may have been asked many times, okay. So let's move now to the next basic. Now we will discuss about the types of the triangles over here, okay. So firstly there are basically two types of the triangles, okay. Types of triangles we will discuss over here, and there are basic two types of the triangle, okay. There are only basic two types of the triangle. So first type of the triangle is based on sides, and another type of triangle is based on angles, okay. So basically there are two types of the triangles. So one is based on sides, one is based on sides, okay, and second is based on angles, so these are basic two sides of these are basic two types of the triangle. Now we will discuss that how many types of the triangles are possible on based on sides, and according to based on angles, how many types of the triangle. So I would say there are three types of triangles possibly to form based on sides, and in the same way we can construct three types of triangle based on angles. Now I'm gonna to tell you the names of these types of the triangles. So as I mentioned you here that triangles based on sides will be three. So what are the names of these three? The names of these three types of the triangles will be, first one will be equilateral triangle, okay, equilateral triangle, and this is the symbol of the triangle. Second one will be isosceles triangle, and third one will be scalene triangle, So these are the three types of the triangle based on sides. In the same way, we have three types of the triangle based on angles, and the names of those triangles are first one will be acute angle triangle, and you already know this, that what is an acute angle triangle? A triangle in which each angle is greater than 0 and less than 90, that will be known as acute angle triangle. And the second one will be right angle triangle, And what is a right angle triangle? A triangle in which any of the angles must be equal to 90. Okay, that is right angle triangle. And the third one will be obtuse angle triangle. Obtuse angle triangle. And what is an obtuse angle triangle? An obtuse angle triangle is that in which any of the angles is equal to is greater than 90 degree. That will be obtuse angle triangle. So these are the types of the triangle. Now I'm going to discuss a very important thing with you. Okay, and the thing is that what is examiner is going to do with you. Many times the length of the sides will be provided to you in the question. Okay, length of the sides will be provided to you, understand that? And he is going to ask you the name of the triangle, and options will be provided based on sides. Okay, I'm going to tell you by providing you an example. Okay, suppose in the question the examiner is going to say you that the length of the sides of the triangle is 3, 5 and 6. Okay, and the examiner is going to say you that name the triangle. What will be the name of the triangle? Name the triangle. Okay, this is the question, and I have the options for you, and the options are number one option is acute angle triangle. Acute angle triangle. Okay, and the second option is obtuse angle triangle. And the third option is right angle triangle. And the fourth option is none of these. So these are the four options, okay, have been provided over here, okay, by the examiner. And listen to me, length of the sides is provided 3, 5 and 6 centimeters, and we have to tell the name of the triangle, and these are the options. Because if options are not provided to you in the questions, any student may say that length of the side is 3, 5, 6, so and not a single side is equal, and he can say this is a scalene triangle, he can say that. But I would say to you that the options are based on angles and the length are provided. Okay, and I have seen many of the students saying that the option will be none of these, answer will be none of these. How is it possible? Okay, firstly check out that with the help of 3, 5, 6 can you form a triangle? Yeah, we can form a triangle. How did I find out this, that we can form a triangle over here? By applying the conditions we have discussed right here. What were the conditions? Sum of two sides must be greater than the third one. So sum of 3 and 5 is 8, it is greater than 6. Sum of 6 and 5, it is 11, it is greater than 3. Sum of 6 and 3 is 9, it is greater than 5. So I can say sum of any two sides is greater than the third one over here. So we can easily say that a triangle can be constructed over here. Okay, so it is quite simple. A triangle can be easily constructed over here. It is quite simple. Now we have when triangle is possible to construct, so none of these cannot be the answer. Now answer must be acute, obtuse or the right. Okay, if you really want to answer this question, you have to better understand first the Pythagoras theorem. So before the simplification of this particular question, I'm going to let you know the Pythagoras theorem. Okay, let's move to the Pythagoras theorem. Anna, so firstly we will discuss Pythagoras theorem. Pythagoras theorem. So what is the Pythagoras theorem? I want to tell you. Okay, most of the students understand that that the Pythagoras theorem can be applied on right angle triangle only, but it's not true. But to make you better understand, I'm going to start with right angle triangle. Okay, so what is a right angle triangle? A triangle in which an angle is equal to 90 degree, that is known as the right angle triangle. So this is a triangle, and name of this triangle is ABC, and angle B is 90 degree. Okay, and the side opposite to 90 degree will be known as the hypotenuse. So this is hypotenuse, and this is perpendicular, and this is base. Okay, there is a very basic rule in a triangle that side opposite to the largest angle will be largest. So this is triangle ABC, and angle B is the 90 degree, and it is the largest angle. So side opposite to this angle B will be the largest side. So length of AC will be the greatest. Understand that? And you have studied it like that h square equal to p square plus b square. Okay, according to you, this is only the Pythagoras theorem, and you says that hypotenuse square will be equal to perpendicular square plus base square. Now I'm going to tell you in my own words. As I told you that side opposite to the largest angle will be the largest. Okay, so I would say that hypotenuse is the largest side. Now listen me very carefully. Okay, listen me carefully. If length of the sides is provided, what you have to do? Firstly, get the square of the largest side. And now if square of the largest side is equal to sum of square of remaining two sides, square of the largest side is equal to sum of square of remaining two sides, then triangle will be right angle triangle. Then triangle will be right angle triangle. Okay, it means it may be possible that the square of the largest side may not be equal to sum of square of remaining two sides. If square of the largest side is not equal to sum of square of remaining two sides, triangle can be formed obviously, but not the right angle triangle. It means if somewhere you find out that square of the largest side, we are mentioning that with hypotenuse everywhere, square of the largest side is greater than sum of square of remaining two sides. If square of the largest is greater than sum of square of remaining two sides, then triangle constructed over there will be obtuse angle triangle. Triangle constructed over there will be obtuse angle triangle. And it is a very basic simple rule. Okay, and questions have been asked many times on these conditions. So this is also the part of the Pythagoras. Okay, and one more rule we have over here. Okay, if square of the largest side is less than sum of square of remaining two sides, then the triangle constructed over there will be acute angle triangle. Okay, I will say that. So I can say that h square less than p square plus b square, h square less than p square plus b square. Then triangle constructed over here will be acute angle triangle. So the triangle over here will be acute angle triangle. So we have these three conditions, and all these three conditions are the part of the Pythagoras theorem. Okay, now we are moving to our questions. Okay, we will discuss the question now. We can simplify it over here now. So in the questions, length of the sides is provided like 3, 5 and 6, and whatever I told you, what we have to do first, we have to get the square of the largest side at first. So what is the length of the largest side? It is 6. Firstly, we will get the square of the largest side, and square of the 6 is 36. So I would say it is h square. It is h square. Okay, now get the sum of square of remaining two sides, and remaining two sides are 3 and 5, and the square of these two sides will be, square of 3 will be 9, square of 5 will be 25, and sum of square will be 34, and this is p square plus b square. Now you tell me that square of largest side is greater or less or equal to the sum of square of remaining two sides, and the answer is obvious. The square of the largest side is greater than sum of square of remaining two sides. So we can say here that the triangle constructed over here will be obtuse angle triangle. Okay, so we can construct an obtuse angle triangle over here, obtuse angle triangle here. Understand that? So concept is very easy, but you have to keep the concept in your mind. Okay, on your fingers. Understand that? Now I have one more question for you to discuss, same kind of questions. Let's suppose length of the sides of the triangle is 5, 6 and 7, and you have to name the triangle. Options are same: acute angle triangle, obtuse angle triangle, and the right angle triangle. Which kind of triangle can be constructed over here? And we are going to simplify in the same way. Okay, firstly we will get the square of the largest side. And which one is the largest side? It is 7. So firstly we will get the square of the largest side, and it's 7. So square of the 7 will be 49. and 49 means we have calculated h square. We have calculated h square. Now we will get the sum of square of remaining two sides, means we will add after getting the square of remaining two sides. So square of 5 will be 25 and square of 6 will be 36, and sum of these is 61, and this is 61, sorry, 61. Okay, so this is 61 is p square plus b square. Now you tell me h square is greater or less or equal than p square plus b square. So you are going to say that h square is less than p square plus b square. So we can surely say that the triangle constructed over here will be an acute angle triangle. Acute angle triangle. Understand that? So it is quite simple that with the help of these conditions and by understanding the Pythagoras theorem in a better way, we can answer such kind of questions. And these questions have been asked previously. Okay, these are not self-made examples by me. Understand that? These are taken from the previous year questions papers. Got it? So these were the conditions of identifying the triangle based on angles if sides are provided. And secondly, we have discussed the conditions of the triangle, how to calculate the range. Understand that? Now a few small things I'm going to tell you related to the triangle. Okay, firstly we will discuss two very basic things. Okay, firstly I'm going to discuss two basic rules. Okay, and these rules are very important, and many times questions have been asked based on these rules, and these rules are not a kind of theorem. Okay, means questions will be provided based on these rules, and if we are going to keep these rules in our mind, we can calculate the questions by giving less time in the question paper. Okay, I can say our time over there. So what is the rule number one? Suppose we have any kind of triangle. Okay, suppose the name of the triangle is ABC, and I have three vertices over here. One is A, one B, and one is C. Okay, so choose any of the vertex. I am going to choose vertex A, and for firstly I am going to draw the angle bisector of angle A. Okay, so I drew the angle bisector of angle A. This AD is the angle bisector of angle A. Angle bisector means this AD is going to divide angle A into two equal parts, and I'm mentioning over here AD. What is AD? AD is angle bisector. AD is angle bisector of angle A. AD is angle bisector of angle A. Now I'm going to draw an altitude from vertex A. Okay, and I am saying AE perpendicular to BC. AE perpendicular to BC. So what are the conditions provided here? A triangle is provided from a single vertex, angle bisector and altitude both are drawn. Okay, angle bisector is also drawn, and perpendicular or altitude from the same vertex is drawn in the question. Okay, in the condition. Understand that? Now the examiner is going to ask the angle formed between bisector and altitude. So he is going to ask you the value of angle EAD. What will be the value of angle EAD? Okay, EAD. So now listen me very carefully. If you want to calculate angle EAD, how to calculate this? Firstly, tell me which vertex is used to draw angle bisector and altitude. You all are going to answer me that vertex A is chosen just to draw the angle bisector and the altitude. Understand that? Now the angle constructed between bisector and altitude will be difference, half of difference of remaining two angles. Angle EAD will be equal to angle B minus angle C upon 2. So this will be angle EAD. This will be angle EAD. Understand that? And it was a very easy concept. Okay, I can give you an example. in over here, and you can calculate that. Understand that? And this is also a question taken from the previous year question paper. Okay, so question is that here is a triangle PQR. Okay, here is a triangle PQR. Okay, and it is mentioned that angle Q is equal to 60 degree, angle R is equal to 20 degree. These two things have been provided, and it is also mentioned that in the question that PS angle bisector of angle P. PS is angle bisector of angle P. PS is angle bisector of angle P. This is the first condition. And PT is perpendicular to QR. These are the data. This is the data provided in the question. Okay, and we need to calculate. We need to find angle TPS. We need to find value of angle TPS. What will be the angle of TPS? If you know the rule, basically, okay, you know the rule properly, you are going to answer these questions within fraction of seconds. Okay, within a few seconds. So firstly, I'm going to draw the diagram for your better understanding. So this is the triangle PQR, and in the question it is mentioned that PS is angle bisector. Here it is mentioned that. So I have drawn PS and it is working as the angle bisector. Now it is mentioned that PT perpendicular to QR. So I have dropped it PT perpendicular to QR, and we need to calculate angle TPS. This angle we need to calculate, and this is T. So we know that angle TPS will be equal to angle Q minus angle R upon 2, difference of remaining two angles, and the value of Q and R provided 60 and 20 respectively. So difference of 60 minus 20 will be 40, and 40 will be divided by 2. So angle TPS will be 20 degree. So this is the answer, and this is our answer. Okay, hope you have understood this. Understand that? So concepts are quite easy. Now I have one more rule to discuss with you. Okay, and this rule is also very simple. Rule number 2. Okay, what is the rule number 2? Rule number 2 says that, okay, rule number 2 says that, let's you have a triangle. You have a triangle, and the name of the triangle is ABC, and this is the name of the triangle ABC. Understand that? Now examiner will provide you some kind of data, or you can say some kind of the conditions, and you have to follow those conditions. What is he going to do? He is going to draw the bisector of an interior angle and the bisector of an exterior angle, okay, on the same base. I mean to say, suppose the examiner is saying you to draw the interior angle bisector of angle B. Which kind of bisector? Interior angle bisector of angle B. So I have drawn the bisector of angle B. This is the bisector of angle B. It means both part of the angle B are going to be equal. Let's suppose upper part is x degree, so lower part will be x degree. Now he is going to tell you to draw the bisector of an exterior angle on the same base. On the same base means on same side. I have taken bisector of angle B, so on side BC. Now I will draw the bisector of angle C, but of the exterior angle. So this is the exterior angle of at vertex C. Now I'm going to draw the bisector of exterior of angle C, and these interior and exterior are meeting at point D over here. Okay, and I mean to say that if it is bisector, then it will be y degree, and this will also be y degree. Now in the given figure or the diagram, bisector of two different angles are drawn. One is interior angle bisector and another is exterior angle bisector, and these two bisectors are going to intersect to each other at point D. So examiner is going to ask you the value of this angle which is constructed at intersection point of both kind of angle bisectors. So what will be the angle value of angle BDC? What will be the angle value of angle BDC? So listen me carefully. The value of angle BDC will be equal to half of angle A. Half of angle A. Okay, angle A by 2. So how to remember this? Okay, very easy concept, and I'm making you understand here by drawing the picture. But if you are understanding it well, you don't need to draw the picture in the question paper if question is asked on this particular rule. Okay, so listen to me carefully. Firstly, tell me the bisector of which two angles are drawn. So you would say that we have drawn the bisector of angle B and C. Angle B and C. Then the angle constructed on intersection point of these two bisectors will be half of remaining angle. I mean to say bisector of B and C is used. So which angle is remaining of the triangle? Angle A is remaining. Angle A is remaining. So angle constructed at intersection point will be half of A. I mean to say, if you were drawing the bisector of A and B, so bisectors of A and B are drawn. One is interior, another is exterior. Then angle at intersection point will be half of C. If you are going to draw the bisector of angle C and A, then angle at intersection point will be half of angle B. Understand? So in today's class, we discuss a few better rules and quite important. Okay, and questions have been asked many times from these rules, following these rules. Okay, hope you have understood all these concepts properly. In the next session, we will discuss the questions which were previously asked in different CDS examinations. Okay, and thanks for today's class, and we will meet further on next Sunday probably. Thank you so much.